Happy Thursday, May 21st. I'm a little bit late getting this video posted to you guys, but let's get right to it. So just want to remind you, tomorrow you have an assessment, all students, underclassmen, and seniors. It is your final assessment, seniors, for your math high school career. Assuming you're not coming back or have to make anything up. So good luck to you on this final assessment. Well, I guess besides the final exam, but your final core subject assessment. And then I will have information to you soon about your final exam. I'm actually just waiting for the information from my boss and stuff. So as soon as I have that, you guys will have the information too. So that information was for seniors. But most importantly, tomorrow, everyone, you're going to log into Google Classroom as you do. And just like before, you're going to complete the assessment, take a picture, scan it. Some of you are using the tablet. So if you have a tablet and you're using a PDF type program and then doing it that way, completely fine. However you've been submitting your work is wonderful. Continue to do that. Just wanted to give you a heads up that you'll be doing that tomorrow. And it's on Monday, Tuesdays, and today's lesson. I don't have a review sheet, as I said early in the week, so it's going to be on you to use today to review the topics. All right. So I'm going to try to give you as much time to let you do some review on your own and be ready for tomorrow. But with no further ado, the last topic of the day or of this week is called the product and power properties of logarithms. Okay, so this week's been all about logarithms. They're just a fancy word for exponents. So on Monday, you evaluated and used logarithms to convert exponential forms and vice versa. I'm saying that kind of weird, but if 2 to the third equals 8, you should be rewriting that in log form and vice versa. And then on Tuesday, you solved equations using logarithms. So Wednesday, you had the day off. Today, product and power properties of logarithms. Simple, you'll see. Let's go. Whoa. All right, so the product property. All right, product we know means the answer to multiplication. So when we look at this rule here, I see right here the log base b of a times b. So that's weird looking, no doubt. But basically what it's saying is if you have a logarithm and there's two parts inside being multiplied together, all right, so if you see a log, any base, it could be invisible 10, it could be a 4. If it's the natural log, you would actually see ln right there. We talked about that a little bit, but it doesn't matter. All I'm saying is if you see a logarithm, what if it's an invisible base 4, 3, whatever, but inside what immediately follows is a multiplication of two things. It could be 3 times 4, 5 times x, whatever, but if you see multiplication, then this rule says you can rewrite that. You can break that up as log base b of the first factor and log base b of the second factor. So you actually make two logarithms and you separate it by addition. All right. So that's the rule. That's what this says. I'll leave it there for you to copy down. Log base b of a times b expands, right? You have a single logarithm on the left. It expands into two logarithms, log base b of that first factor, log base b of that second factor. Here's an example. Suppose I had log base 3 of 4 times w. What does this rule say? We can expand this logarithm into two logarithms. Log base 3 of my first factor is 4. What separates them? Addition. Log base 3 of w. That's what it says, right? So last but not least, there's that. So it's like that first factor, a, is really a 4 here. So there you see it there. My second factor is a w. So my second term is a w. We separate it into two logarithms separated by addition. That's it. It's not a hard rule. Take some practice studying, but hey, you can do it. There's actually an easy way to study. You know, logarithms are another word for exponents. What do we know about this right here? Base 2 to the third times base 2 to the fifth. What do we do with exponents when we multiply them? You've done it in 8th grade, Algebra 1, Part 2, in and out of this course. We talk about it, then put it to the back order. Talk about it. So at this point, you should know it like you know your name. When you multiply same bases, you add the exponents, right? So putting it together, if logarithms are another word for exponents, when you're multiplying, you can break it up into an addition problem, right? So this is a much easier way to memorize an important rule. Wonderful. Let's move on to the power property. All right. The power property says if you have a single logarithm, any base, a raised to the c power. So inside here, you have something raised to a power. Then you can break that up into whatever that power is times the logarithm base b of a. Weird, crazy. Look at it for a minute. See if you can digest what it's saying. But I gave a hint underneath it. Basically, logarithms bring exponents down. So here's an example of how we're going to use this. In a minute, if I had log base, I used 3 a minute ago. Let me use 5 of x to the 12th power. How can I use the power property? I'm allowed to write 12 because that's the exponent, log base 5, that doesn't change, of x. That's it. 12 times log base 5 of x. That's how we use the power property. Simple. Okay, so 2 properties. We've addressed them. We're about to apply them. The product property, if you have a logarithm, things being multiplied, you separate it with addition. Power property, you bring the exponent down. Got it. On to some practice. And I'm going to go full screen for this practice, but make sure you have your volume up and listen. So the direction here asks us to expand each logarithm. So in number 1, I have a logarithm. What's the invisible number there? I hope you said 10. We call this the common logarithm, just reminding you of that. But there's an invisible 10 there. Don't fill it in. It's not illegal. You won't go to jail for doing it, but just don't do it. It's purposely done that way. Just giving you a little reminder. Common logarithm, it's invisible 10. So when we separate this using the product property, we're going to write the common log of x plus the common log of y. And we are done. Let me give myself a little more room there. Great. Number 2, the common log, again, an invisible 10 there, common log of u to the third. How can I rewrite that? Using, well, I can use the power property, right? I have an exponent of 3, so this is going to come down. Logarithms bring exponents down. Simply 3 times the common log of u. Done. Who can't do this? I don't know. All right. Number 3, I didn't even want to put on here, but I just wanted things to look pretty. So I wanted an even amount of problems. So it's very similar to number 2. There's nothing to even think about here. 6 times the common log of x. Done. Seems like the computer program I used all common logs here. Doesn't have to be that way. It is what it is. But actually, what I wanted to give a moment to was number 4. How can we write that? A little bit of a challenge. Or is it? First hint, and my only hint. Think back to last week, I think it was. Or was it 2 weeks now? My time frame is all off. I don't know about yours. I don't even know what day it is when I wake up sometimes. Like, is it the weekend? Is it Monday, Tuesday? Right? But anyways, seriously, back to the point here. What do we know about square roots as exponents? Square roots are 1/2 exponents. Awesome. So we can call this log x to the 1/2, right? So that's not a logarithm property. That's square roots are 1/2 exponents. And now we can use the log property that says, hey, that's an exponent inside a logarithm. Bring it down. 1/2 log x. Well, that was kind of fun in a way. It was fun. I feel smart doing that. Don't you? No, Mr. Rodolewicz, you're crazy. I know that, but don't you feel smart? That was my question. You do. You do. You're an inner math geek. It's at this point in the year people start to say, I actually get it. Right? I wish I could see you guys in class because literally it's this point in the year where we start winding down and people say, I actually kind of get this stuff now. Friggin' logarithms. Logarithms. Go around the world. Most people are deathly afraid of them. Not my students. You guys are amazing. All right. Anyhow, let's get back to moving on. Other things. So now we're going to work in reverse. We're going to work in reverse. We're not going to expand, but we are going to condense expressions. What the heck does that mean? Well, if we just expanded something, condensing it is the reverse. So in number 5, I see 2 common logarithms separated by addition, so I can condense it to a single logarithm. And I know if 2 logarithms are separated by addition, they can condense to a product, x times y. Done. Literally, I'm working backwards of number 1. I'm working backwards of number 1. Look at this. Number 1 and 5 are just reversed. In number 1, the verb was to expand. But number 5 literally takes this answer and says, hey, whoa, well, I don't know what's going on. I lost my spot here. It literally takes this answer that we came up with in number 1 and gives it to us as a question, but the verb says condense. It's like we're working backwards. We're working backwards of what was given to us. All right, so that's it. So what do you think about number 6? How could you condense this? We're still using the power property, but we're not bringing the 3 down. We're bringing it back up. This is going to go back up in the sky. So this is the common log of x to the 3rd. Done. All right. So just pay attention to your verbs, but it's literally just 2 properties. Wonderful. Next, I think we're done with that. Oh, nope. These get a little more interesting. Okay. So be careful. This is about as challenging as you'll see. Now, students too quickly jump here, and they're great students. They're great thinkers, but slow down, okay? I see 2 logarithms as well. I see a plus sign as well. But, do you see log of something plus log of something else? Kind of. We have an issue. We have this 12 and 3 in front, right? So you can't combine them yet. You can't combine them yet using the product property. Your first step is to bring the exponents up, okay? So if you have a number that's multiplying a logarithm, before you condense it using the product property, you have to bring the factor up. So let me show you exactly how we're going to work this. The correct way to do this is to bring the exponent up, the base 7 logarithm of x to the 12th. That takes care of the first term. And now we're going to do the same with the 3, the base 7 logarithm of y cubed. There's step 1. That's what I'm hinting at. You have to bring the number part up first. Then you can use, hey, I have a log plus another log. This is when you can condense them. So now we can condense as the base 7 logarithm of, well, what are the 2 things? X to the 12th and y to the third. You separate them with multiplication. Done. Okay, so I said this one was more interesting. And this is typically a little more challenging. That's why I put it here. But if you need to rewind this video twice, 3 times, 5 times, awesome. But it should make sense to you, okay? You should be able to say, all right, I didn't get it the first time. Oh, now I'm seeing you got to bring the number up, got it, and then you can rewrite it as multiplication. That's the correct ordering. I'm not even going to show you the incorrect ordering because I don't want you to do it. I'm just going to show you the correct ordering. Number 8. Okay. Well, the first thing I notice is there's no number in front here. There's no number in front here besides the invisible 1. I should say that carefully. All right. But there is a number in front of this logarithm. So I'm going to take Mr. Rodolewicz's rule here and bring that 5 up as my first step. So I'm not going to do anything. I'm not going to do anything. I am going to do something. I'm going to call this log of the common log of c to the 5th. Great. Now what can we do? Well, now once we have addition, right? Addition separating logarithms, we can write this as log of a times b. That takes care of the first two. So I still have this common log of c to the 5th. Now what do? Oh, I do it again because I have log separated by addition. So I do it again. What do you mean do it again? You multiply it all together. Log of a times b times c to the 5th. Done. All right. Could we have gotten there a little bit quicker? Yes, we could have, right? I think we could have skipped this step. Looking back here now, I couldn't skip this first step. I definitely have to do that first. But then I could have looked right here and said, oh, wait, I have a plus and another plus. I could just multiply a times b times c to the 5th, and I would have got my final answer correctly. All right, so if you want to skip that step I crossed out there, please do so. It's efficient. Onwards, and we're almost done. Solving equations. Okay. Full screen this. Just listen up. We're almost done. A few more questions. Here's some other types of logarithm equations. The first thing I notice, I have log base 2 on the left. On the right, I have a log base 2. So here's a rule. Here's a mathematical fact. When you have log base 2, blah, 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 like this is the blah, 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 equal to log base 2 of some other blah, blah, blah. So this is the some other blah, blah, blah. Or it could be base 3 or base 4 or the common log or natural log, whatever. But if you have a log base b equal to a log base b, you can just cross these right out. Come on. Really? Yeah, that's it. You just got to know what to do. Practice, study, do it. When you have a log equal to a logarithm that are the same bases, cross them out and just solve what's left over. So we have 4a minus 3 equals 5a minus 5. Oh my gosh, this is middle school algebra. I'm going to subtract. I'm going to add 3 to both sides. At the same time, I'll subtract 5a just to make life a little bit quicker for myself. So by doing that, 4a minus 5a, let me go a little full screen for you guys. 4a minus 5a vertically is negative 1a. This makes 0. This makes 0. And this makes negative 2. And now when I divide by the negative 1 here, basically we just switch signs. A is 2. But all I just did there was basic algebra. Basic algebra. There's other ways to do it, but at the end of the day, you're going to get the same answer of a equal 2. The algebra 2 part of this was the first step, crossing out the common, this, I don't want to say common logs, that's bad, but the same logs on both sides. Basically, it's the comparison property, right? You have log base 2 on the left, log base 2 on the right, same thing, gone. So their inner parts have to be equal. Done. All right, there's nothing to do. And we can make the same argument here. I almost want to skip this one. All right, I am going to skip this one. For time's sake, there's nothing to go over. There's nothing new here. Cross this out and then do the basic algebra. So I'll leave you to do that. Oh, I didn't put the answer up, but I'm check your work. All right. If you want me to check your work, send me an email. I want to move on to the more challenging ones. Right. So number 10, just basic algebra to follow there. Let's go on to number 11. Okay. So now you got to be careful. Be careful. This is where mistakes happen. See what I did in the first two? I had a logarithm, blibbity blah, equal to a logarithm, shmebbity bib, right? But I had a log equal to a log. That cancels out. Number 11 isn't quite that. Number 11, we have a logarithm plus a logarithm equal to a logarithm. So if you just cross this all out, you would be 100% wrong. Do not do that. Do not do that, right? So in first, you want to condense. Condense. We've seen that verb before. We've seen that verb on the front side of this worksheet, okay? So how do we condense two logarithms separated by addition? Well, the first thing we do is make sure there's an invisible 1 in front of each logarithm, which there is. Good. So now we can condense these. Oops, didn't mean to do that. By writing this as log base 4. I'm going to use a bracket here of the 2 times 6 minus 2x. All right. Let me slow down for a minute. I don't want to rush this. Let me just re-emphasize what I'm showing here. Log base b of a times b is log base b of a plus log base b of capital B, right? But when we condense, we're working this way. So I'm taking this logarithm and this logarithm, writing it once, and I'm taking the inner parts, the 2, and I'll just call it the group, the 2 in the group, and I'm going to multiply them together. I haven't done the multiplication yet, but I'm about to, all right? So that's what took place there. And it looks like I lost some of my coloring. All right. So we have log base 4 of 2 times the group, 6 minus 2x. And on the right-hand side, nothing changes at all. Log base 4 of 23. Okay. Now this is similar to numbers 9 and 10. How come? Scroll up here, look at this. Because in numbers 9 and 10, we have a logarithm equal to a logarithm. That's it. There's not multiple logarithms. It's one logarithm equal to another logarithm. We have that now. We have a log base 4 equal to a log base 4. So now that there's just a single logarithm equal to another similar, identical single logarithm, we can cross these out. Now it's legal to do it. So what remains? 2 times 6 minus 2x equals 23. And it's basic algebra from here. Basic algebra. Use the distributive property. 12 minus 4x equals 23. You're going to add 12 to both sides. I'm out of room. I can't zoom anymore further down. Oh, yes, I can. Lies. Thank you. I'm sorry, why did I say add 12? I'm glad that happened for a reason. I can subtract 12 from both sides, which makes this an 11 equal to negative 4x. And you divide by negative 4. X is 11 divided by negative 4. Good enough for me. I'm not even going to use a calculator for decimal form. That's my answer. All right, so just basic algebra from that point on. Again, if you need to go back and rewatch this video over whatever parts you need to, please do so. But those steps are just your basic algebra steps. Distributive property, subtract 12, divide by negative 4, and you're good to go. All right. So number 12 is almost identical to number 11, but I will do it out. Okay. So once again, the illegal way to do this is to just cross out the logs. Can't do that, right? You want to condense. So we'll condense these. And this is called the base 4 logarithm of, I'm going to use a bracket, 5 minus x times 6 equal to 1. Uh-oh. Wait a minute. I have a log base 4 on the left, but I don't have a log base 4 on the right. My friends, go back to your Tuesday thinking. You solved equations like this. You already solved equations like this. How do you solve equations if you have a logarithm equal to a number? So I'm going to slow down because this is the last question anyways. Tuesday, you did that. You solved logarithms equal to a number. How? By rewriting it in exponential form. We have a logarithm equal to a number. So, oops. Yeah, I wanted to do that. So from Tuesday's lesson, we rewrite this, here we go, in exponential form. The basis for this becomes the exponent to the first power is 5 minus x in a group times 6. So sorry about that, but we're good. All right. I'm going to clean this up in a minute. You might want to come back to this part in the video. It's 27 minutes in a few minutes, but all right. Sorry. Little background distraction. So from here, we have basic algebra to complete. Okay. 4 to the first power is 4. I can distribute the 6, kind of distributing it in a backwards way, but that's fine. 30 minus 6x. Subtracting 30 makes negative 26. And dividing by negative 6, you get x equals, a negative divided by a negative becomes positive. So we have 26 over 6, which would simplify to 13 over 3. All right. I probably lost you there because of some background distraction, and it wasn't exactly like what we were doing prior to that. So I want to take a step back and wrap up this video by looking at the big picture here, okay? By looking at the big picture here. Number 9 was the introduction to this. I'm going to clear out all this junk and just use a highlighter. What do I see here? A single log base 2 equal to a single log base 2. So when you have identical logarithms, singular on both sides, cross them out. Legal, that's the way to do it. In number 11, we did not have a singular logarithm on the left-hand side. We had a base 4 logarithm plus a base 4 logarithm. So we had to use the property to condense them, which we did. When you condense with addition, it becomes multiplication. So that's what I have written there. But then in this line, we have a single logarithm base 4 and a singular logarithm base 4 on the right. Now we cross them out. I hope this is clear to you. The difference is number 12. We didn't have a singular logarithm on the left. So yes, condense, which we started to do. But now there wasn't even a logarithm on the right at all. So how do you solve that? You rewrite it in exponential form. This is our base. So we wrote base 4. Let me go back over here. 2 to the third equals 8 means log base 2 of 8 is 3. I want to use that example. And this changes places with this, okay? So the same idea here. The base stays the same, but this part and this part trade sides. Is that ringing a bell once I put those arrows in? Is that ringing a bell to Tuesday's lesson? It should at this point, right? Those arrows shouldn't be, because I use those arrows a lot in Tuesday's lesson. So that's how we did it. Maybe now you got it. I got it now, Mr. Alice. Now I see what to do. After we get rid of all that schmiggity schmack, that's a weird word, weird phrase. Everything that followed here is basic algebra steps. Distributive property, adding and subtracting both sides, so that shouldn't be the issue. All right. Hey, there were the answers. So the answer number 10 is there. My bad. All right. So I'm going to post this on the Google Classroom as well as another worksheet for you to practice. My neck is itchy. You didn't need to know that. Good luck, seniors. Well, I'll talk to you tomorrow. I feel like I'm rushing the gun a little bit. We still have a assessment tomorrow, underclassmen and seniors. But good luck, seniors and underclassmen, on that tomorrow. Good luck in the rest of your coursework. And seniors, pay attention to your emails or Google Classroom. As soon as I get information about what your senior exam is going to look like, I will have a review sheet for you guys. So seniors, you will have a review sheet for your senior exam. That's for sure, but not for tomorrow's assessment, which everyone's taking. I'm all over the place. You know, that's typical me. You got stuck with me. Luckily, you didn't get stuck with me in the classroom. Seriously, guys, I miss you all. Hopefully, you're doing well. Get your work done. And shoot me in any email questions that you have. I'll do my best to get back to them as soon as possible. I do have a couple of the classes to get through, so bear with me. But if I don't get back to you in an hour or two, check periodically. I'll definitely get back to you this afternoon or maybe around 2 o'clock, whatever. But anyways, bye guys. Take care. Stay safe. Wash your hands. Social distance.